Hello, ladies and gentlemen, and welcome back here on the industry stage at Formnext 2024. I hope you had a lovely lunch break with a fantastic food, and it's good to have you back here. I hope you got the energy to enjoy our full afternoon program. There's a lot of highlights to come, so you can look forward to it. We will kick off the afternoon with a topic that is super important all across our industry, but not only in our industry. It's a topic of sustainability. This is what this whole afternoon is about. And we want to categorize the term a little bit so that we get a perspective before we start and dig into discussions. So in order to do that properly, we need, of course, an expert, okay? And the first person to speak here on stage is none other than Sherri Monroe, who is Executive Director of the Additive Manufacturer Green Trade Association. And she is undoubtedly an expert in this field, and therefore I'm delighted to welcome her here on stage. So please, a warm applause and welcome Sherri Monroe. Sherri, good to have you.
And how are you?
I'm fine, thank you.
Good. Hey everyone, glad to be here and excited to be talking about sustainability. What a better topic to be talking about than sustainability. As Sven mentioned, I'm the Executive Director of the Additive Manufacturer Green Trade Association, and we are a global trade association focused on additive and sustainability. And our real objective is to increase adoption of additive manufacturing because we believe this is a more sustainable process when applied across the enterprise. Across the enterprise is going to be a key part of what I'm going to talk about today. Let me grab my clicker here. So one of the first things that I am if I can get this to go, there we go. One of the first things that I'm quite often asked is, what does sustainable manufacturing mean? And what does it mean to me, and what does it mean to our organization? This is the definition that I use. It's really about leveraging technologies to maximize resource efficiency and reduce waste. It's really just that simple. And so the word sustainable or sustainability, either one, are really rather general terms. What does that mean? Does it just mean environmental? What does it mean? It really means all those things. So whether you're thinking about environmental and social sustainability, or you're thinking about the economic viability of a company, it really still comes right down to resource efficiency. The key is, what are the resources that you're considering when you're evaluating this? And we are going to talk about that. So as we start looking at sustainability, those resources, you know, when we think about AM, we think about comparing traditional manufacturing to additive, we're always really quick to think, okay, energy, material, maybe the output waste, but there's a lot of other things that quite often don't get considered in there. Things like capital, having money tied up, time. Time is a big resource that additive can really do a lot about. Labor, opportunity, and risk. So opportunity, if you're doing this, you can't be doing that. The other thing's a risk. We're very familiar over the last few years about risks in supply chains. So that's an important one to consider as well. And when I talk about these, for people who've talked with me before, you've heard sustainability and resource efficiency sometimes used interchangeably. And there's a reason for that. For some people, I'm from the US, sustainability is not such a hot topic there at times, maybe not for a few years yet. But resource efficiency is super important. So I was at a conference earlier this year that was MIL-AM. It's in the US. It's what it sounds like. It's all about additive manufacturing, and it's military. I went just because I wanted to see, do these people even talk about sustainability? I don't know about you, but when I think about the US military, I'm not even sure they're concerned about money. They seem to have endless money, and I'm not sure sustainability is a topic for them. So I went and I said, you know, is sustainability an issue for you guys? And they kind of looked at me like, gosh, that's not really something we think about a whole lot. I said, okay, what about resource efficiency? Oh, let me tell you, they are all about resource efficiency. Because especially when you think about remote locations, forward-leaning positions, potential combat situations, they have to be very conscious of the energy they're consuming. They have limited supplies. How are they managing their resources and their materials? but also in remote locations, like there's a project on the island of Guam that is out in the Pacific. And so they have to be very conscious of energy use, of material use, and even waste. And even if they don't care about the planet, the island is, I don't know, about the size of this stage. Where are you going to put it? So that's a concern for them as well. So creating less waste, and the waste that they do produce, being able to somehow repurpose, revert, recycle, and use that again is a really important issue. And so for folks who maybe say sustainability is not an issue for us, I can guarantee you if you talk about resource efficiency, very likely that will be an issue. And so really we could change these terms to be environmental benefits and economic outcomes, because that's really what it comes down to. Whether you're talking about money or you're talking about saving the planet, it really comes down to managing those resources better. And I will tell you, I'm not concerned about the motivation. If you tell me you're doing these practices because you want to save the planet, because you need to be economically viable, because your government is forcing you to do it, your shareholders are forcing you to do it, I always say it's a little bit like eating your carrots. I don't care if you're eating them because you like them or because they're good for you. Keep eating your carrots. And I look at additive the same way. I'm not that concerned about your motivation. Whatever's bringing you to the table, let's do more additive and let's really look at what it can do for us. So as I look at additive manufacturing, we start with 3D printing. And we look at the benefits of 3D printing itself, just the printing. So what are some of those benefits we see? Well, especially when we're talking about sustainability, for any of your family or friends, you talk about 3D printing there and you tell them what it is, they're like, oh, it's got to be more sustainable. We're not cutting away all that material. And you go, well, yeah, it's a little bit more complicated than that. And it is more complicated than that, but it does start there. So some of the benefits around sustainability and economic viability that we see just from the printing part is we're not cutting away all that material. Also, the reduced tooling required to do this. Design iteration, which is the reason rapid prototyping was the first place that additive really took off, or 3D printing took off. And so those basic efficiencies are there just in the printing process. Now, we also know for the printing process that quite often those material productions, producing powder, can take a lot of energy. So there's some areas where, okay, it's better, it may be a little bit worse, but it really takes some evaluation. And so those evaluations are happening. Next, when we look at the next ring around the set of technologies around 3D printing, that's really what we're talking about in these halls this week, right? Additive manufacturing. And so when you take 3D printing, and I know you guys already know this stuff, but I'm linking it to sustainability. So when we add all of those technologies around 3D printing that make up additive manufacturing, there's a reason we don't just call it 3D printing. But the biggest one really is about design freedom. If you walk around here, the big difference you're seeing between just 3D printing and what we have here is design freedom. What are you able to create? How are you able to create it? How can you be more efficient in those ways? So we've got unique geometries, we've got lightweighting, we've got part consolidation that you simply can't do through any other kind of manufacturing. We have the nearer net shape potential, even if you do need to do some machining. And we've got the monitoring and optimization that really makes additive manufacturing so much more than 3D printing. It's that whole set of technologies. Now, usually that's kind of where we are. When you see any analysis around additive manufacturing in terms of sustainability and economics, okay? I use the word cost to mean both, economic cost and environmental cost, because for the most part, those two things track together, not differently. And we're gonna talk more about that in just a second. So this is a part that we, actually happen to have this part here with me. This is the first research project that we did. This is an aircraft part that goes on a Boeing 767. The part on the left there, it's a machined part. There's 24 of these on a plane. They go on the engine, and that's their job. On the right is the redesigned part. So it's redesigned for lightweighting. And so we did a LCA, a life cycle assessment analysis, and we compared production of these two parts, which based on the way the project was done, kind of came out not a lot of difference. But obviously, lightweighting of a part that goes on an airplane, you can imagine the savings there, both in cost and environmental impact. Reduced jet fuel, reduced CO2 footprint. This is a great story. Now, as part of this project, that's sort of all we studied. The thing we did not study about this project was the durability of the part. And we may actually go back and revisit that project because, as it turns out, Centavia, who made this part, went back subsequent to the study and checked out the durability of this part, how long it lasts. And it's about 30 or 40% more durable. So when you're doing a part-for-part analysis, which is what we all have done a lot of and come up with varying conclusions, when you use for your LCA, your life cycle assessment, your functional unit, what are we going to compare one part to one part? It can come out very negligible. But when if we go back and redo this project, instead of the functional unit being one part, it would be the life of the airplane, because the redesigned part is more durable. So over the life of the plane, we may only need 4 of these and 6 of these. That changes the economics and the environmental impact completely. And so if your organizations are looking at life cycle analysis to do one, or you're reading one, look at the functional unit, because I can tell you, depending on the project, the functional unit can kind of doom your project right from the start, because you're measuring the wrong thing. So that's just something to think about there. And it was really important for this project, and it's important for a number of other projects as well. So the next layer around this, which is a part we don't really talk about quite often. So we've got the 3D printing, we've got the additive manufacturing, which we've got in these 4 halls. The additive strategies is the other part we really need to look at as we're making a case for additive manufacturing. Now, I know sometimes the term additive strategies is used to talk about, like how you're going to print the part and design it and how you're going to put it in the build volume and all that. That's not what I'm talking about. What I'm talking about is how do you apply this set of technologies across a business enterprise. So we're talking about going beyond the part-for-part analysis and things like, what does this part enable me to do? Does this enable me to get a piece of machinery up and running sooner? I'm saving a resource called time and money and CO2 impact if I have to have parts shipped in. Some of the other things that we're looking at in that kind of space is also looking at warehousing. If you're having to warehouse a lot of parts, what are the costs of that? In traditional manufacturing, which we're going to talk about a little bit more in just a minute, you have to produce in very large volumes. And so how many people get caught up in what's the part cost? All they want to know is the part cost, right? We hear that all the time. But I can almost guarantee you that when they're looking at the traditional part costs, there are costs that are not being included because they're assumed to be the same for both parts, right? We have these 2 paths. You start with, aluminum, titanium, whatever. You get the material, it gets converted differently to powder, whatever, and there's an assumption that the 2 paths come back together at some point and that everything beyond that is the same for both parts. But that's not necessarily true if you're really leveraging additive. The inventory carrying, warehousing. If you have to produce in very large volumes, those parts have to be warehoused somewhere and they have to be managed. And there are costs associated with that may not apply on the additive side. Distribution and supply chains. So if you're producing all this large volume of parts all in one location and then have to distribute those, what does that look like, and are those costs being included? And again, those costs may or may not be on the additive side, or it certainly can be minimized through some of the features of additive. So this is kind of a standard chart for looking at order quantities. So as you look at this, and this is true for additive and traditional manufacturing, right? The cost of your part, as you produce more and more and more, it decreases until it bottoms out, okay? That's true for traditional manufacturing and it's true for additive. Although for additive, quite often, it bottoms out at a much lower quantity. So the point of that and why that's so important is that you don't necessarily have to inventory all these parts. So some of the other aspects of that, and I'll just do some really quick math here, so because I know when people are talking, it's hard to keep math in your head. Let's say you need 12,000 of a part over the course of a year. I'm picking 12 for a reason, because there's 12 months. So let's say you need 12,000, or it could be 120,000, it could be whatever. If you're doing traditional manufacturing, you probably have to produce those parts all at one time, in one location, a single design, and then you have to warehouse them for the rest of the year while you burn through them. So just imagine this scenario I've laid out. With additive manufacturing, that quantity at which that price bottoms out and you stop seeing more benefit as you go with higher quantities is much lower. So instead of having to produce 12,000 parts, let's say in January to use for the rest of the year, I can produce 1,000 in January, 1,000 in February, 1,000 in March. And here's what, now you say, but it doesn't matter, I still need 12,000 parts. I'm on board with you. You need 12,000 parts, but you didn't need them all at the beginning of the year. You didn't necessarily need them all in one location. That's not very resilient for your operation to have them all in one location, and there are costs associated with that. So let's say you've made all 12,000 of those parts at the beginning of the year, and in March or April, somebody comes along and says, hey, we discovered there's a problem with this part, or we've come up with a cool addition to this design. Well, somebody's gonna say, well, hey, that's really great. You're gonna have to wait till January for us to implement that change, because we've got inventory sitting on the shelf. We've got to do something with it. So your choice at that point is suffer through suboptimal inventory for the rest of the year, or you have to trash it, recycle it, whatever, which has a big economic cost and an big environmental cost. So that ability to be able to iterate through the year is important. I know we still need to be able to do big volumes, but we don't necessarily need to do them all at once in one location, and we don't necessarily need to do one model. If you think about an appliance manufacturer, you notice how they, maybe for that brand, every knob on every stove is exactly the same? It's not because it's such a great knob, hate to break it to you. It's because they need to produce them in such large volume. So their thing is they don't want to give you any more choice than they absolutely have to because of the constraints of mass production. They have to produce things in such big volumes to get to that price that they want to use parts across platforms. But if you can produce in smaller volumes, you not only do you open up more options around inventory and carrying and distribution costs, but if you go to the product design people and say, hey, we can offer realistically, efficiently, economically, offer our customers more options because we don't have to produce a single part in such huge volumes. This has big implications throughout an organization. Now, these conversations quite often we're having with the team within a manufacturer, a big OEM that's making, I don't know, we'll use appliances again. The guys that are making the parts, they just need to get parts out. They may not care particularly, it's not really part of their responsibility, the warehousing costs or the distribution costs. But if you go to those teams and say, hey, we can reduce our standing inventory significantly, we can free up that capital and we can do other things with it. We can reduce overproduction. We can reduce obsolescence. We can reduce that, we had to print or produce a whole bunch of products but we weren't really sure what demand was going to be, or world events or other events have shifted demand, and now we've got inventory. If you can be more nimble in that by leveraging additive manufacturing, you can gain not only economically, but environmentally along the way. And so this is a big aspect that I don't think we're looking at as much as we should be in this. With our organization, again, we're a global trade association. We have members throughout the manufacturing ecosystem within AM. So everything from powder producers, printer manufacturers, software, and the end users of additive. So I kind of divide the sector into two groups. There's the technology developers, excuse me, and the technology users. And it's really important to have all of them in there because they contribute to the conversation in technology development and adoption. So based on these things that we're talking about here and looking at this additive strategies layer in particular, not only assessing the 3D printing and the additive manufacturing aspects, but those additive strategies. We're working with our members right now to create a framework for this so that when we're talking to companies about additive adoption, when they want to compare, how does this compare to my traditional manufacturing? We need to be able to give them a more clear roadmap framework for evaluating that, because I can almost guarantee you there are costs on the traditional side that are not being calculated in when they're doing that comparison, because they're costs that almost feel like gravity. It's everywhere and nowhere all at the same time, and they just assume those costs to be constant no matter what. So as we develop this framework over the next year or so, we're really excited to have our members participating on that, really identifying what are those things that we really need to be looking at, and how can we better facilitate adoption. And the way we really facilitate adoption is for those people that are looking at it or looking to expand their use of additive within their company. We need to help them understand, here's what you need to look at, and here's how you can effectively compare these two things so that you can get a really good understanding and make the absolute best case decision for your business. So, with that, I will say thank you very much, and hopefully you'll have some questions. And feel free to challenge me on any of this. I'm happy to do that, and love other input. If you've got thoughts on this, we can speak now, or we can also speak later too. So
at least I will do.
Yeah.
That's for sure. But any questions from the audience here? Please feel free to ask whatever you want. If not, I will. Although I must admit, it's kind of strange to ask you now, because we will see you later on the panel.
Right.
And probably I take one or two of my questions away. No, don't get me wrong. So I'm a lot into lean management, and it feels so familiar. I mean, you're talking about warehouse, and the thing is, you brought the example with 1,000 per month is definitely better than 12,000 at the beginning of the year, for sure. How does it come in your perspective that it's never considered the right way, first thing? And now let me ask the second thing later. First one, why is that not recognized or acknowledged?
I think for a lot of companies, it's just not the way they've done things. It's assumed you have to produce in very large volumes. That's just the assumption. And I would also say that number, that really high number, one of the mistakes we make as a sector also is that's a constraint of traditional manufacturing. That's not a benefit that I have to make a lot. That's their constraint. That is the thing that's hobbling them. And then additive comes along and says, that's our goal. Like, that shouldn't be our goal to, how do we put these huge inventories on a shelf? It's how do we, but not so lean to where, we have issues, because we've seen what can happen with a supply chain. But with additive, you can bring so much more of that production, not necessarily in-house, but more in your control. So some of the risks and concerns around lean, I think, are mitigated through additive technologies. Absolutely.
But what you do here, you're having several advantages. Like, for example, if you do only the 1,000 and you do it locally where you need it, then you have another reduction of transportation costs. That would be a next thing.
Absolutely.
By producing decentralized. That would be the next thing. My only concern, there are two questions. I stop immediately. Please, first the gentleman.
Hi, thank you very much for your presentation. I found it personally really nice, the study that you talked about different parts with conventional method and the additive manufactured part in the airplane. I wanted to ask if there's...
Put your microphone a little bit closer to here.
I wanted to ask if there's also some studies that compares with a life cycle assessment and concerning the right kind of functional unit. Also studies the difference between these two manufacturing on demand and also the conventional, like as an example, 12,000 at the same time. Is there anything that you've conducted in this topic?
Specifically about, I'm not sure, I didn't quite get the end.
About manufacturing, the differences between manufacturing on demand with additive manufacturing and with the conventional method all at once, and like conducting a life cycle assessment on this.
Right, so those are some of the things that we're looking at. We have done some studies that reflect some of that information, and we've got studies that are available on our website as well. But that's part of what we want to do, is look at more of that and really evaluate those other aspects around that. And risk is one of them. You know, if you're going more in that lean direction, you do have risk, but you have risks when you have that stuff sitting on the shelf too. That, again, that's a risk quite often that is not considered. I live in Florida. We have hurricanes all the time now. So even just having inventory sitting on a shelf has risk, right? And so, but is that getting counted in? It might get counted in immediately on a lean type of strategy, but there's equally risks on the other side that may or may not be factored.
But my recommendation to you, we will step deeper into the topic in our panel discussion, like in about 25 minutes, when we join the stage again, and talk a lot more about sustainability. Unfortunately, we were running out of time, but I think Sherri will answer your question right beside the stage without any problem. So, ladies and gentlemen, a big applause again for Sherri Monroe. I really enjoyed it so much. Sherri, what's such a wonderful presentation.
Thanks, Sven.
So, ladies and gentlemen, at the live stream, enjoy another few highlights from the fair. I do all the time because I can't walk around, so you should do as well. In about 5 minutes, we will see us back here for another exciting keynote before we step into our panel. So stay tuned. See you in a few minutes. Thank you.